Hello everyone. Hope all of you are doing well. I'm Punya Gupta this side, and today I'll be covering 6 sample questions for CAT 2026. If you are aiming to get into top B schools this year through CAT, I'm sure this video will be helpful for you. So without any further ado, let's dive straight into the questions. So this is the first question. The question is based on number theory. It is a simple yet interesting question. The question asks us to find the remainder when 19 raised to the power 92 is divided by 92. So there are a few approaches for this question. First approach can be to do prime factorization and use Fermat's little theorem to find the remainder. 92 can be expressed as 4 into 23, both co-prime factors, and we can just compute the remainder when 19 raised to the power 92 is divided by 4 and when it is divided by 23. The product will give us the remainder when 19 raised to the power 92 is divided by 92. So 19, 23 and 23 is a prime number and 19 is an integer. So Fermat's little theorem states that a raised to the power p minus 1 will always give remainder equal to 1 when divided by p is congruent to 1 mod p, provided p is a prime number. So from Fermat's little theorem, we can say that 19 raised to the power 22 will give remainder 1 when divided by 23. So this is the first step of our solution. So now we have to find 19 raised to the power 92 when divided by 23. What would be the remainder? But this is very easy to find because 19 raised to the power 22 gives remainder 1. So when we multiply the exponent power by 4, we can say that 19 raised to the power 88 will also give us the remainder 1 upon division with 23. So all we need to find is 19 raised to the power 4. The remainder obtained when 19 raised to the power 4 is divided by 23. So in order to do this, this is very straightforward. 19 square is 361, which gives remainder of 16 upon division by 23. And 16 square is 256, which gives us a remainder of 3 upon division with 23. So thus we can claim that 19 raised to the power 92 will also give us a remainder of 3 when it is divided by 23. So this is the first step of our solution. We have obtained the remainder when the dividend is divided by 23. Now let us find the remainder when we divide by 4. So what we need to find now is the remainder when 19 raised to the power 92 is divided by 4. This is also straightforward. 19 gives us remainder 3 when divided by 4, and 3 square gives us remainder 1 upon division with 4. So 19 raised to the power 92 is equivalent to finding the remainder when 3 raised to the power 92 is divided by 4. And 3 raised to the power 92 will always give us a remainder of 1 upon division with 4. Because 3 square gives us remainder of 1, so 3 raised to the power 92 will also give us remainder of 1. So this helps us to conclude that 19 raised to the power 92 will also give us the remainder of 1 upon division with 4. So now we have to find the number which gives us remainder of 3 when divided by 23 and remainder of 1 when divided by 4. So all these numbers 3, 26, 49, 72 give us remainder of 3 when divided by 23. But only 49 gives us the remainder of 1 when divided by 4. All the other numbers give us a different remainder than 1. Hence our final answer is 49 for this question. So this was one approach for this question using the Fermat's little theorem. Let's look at a simpler approach, or Euler's torsion theorem. So Euler's torsion theorem states that any prime number raised to the power of its torsion will give us the remainder of 1 when divided by the number of whose torsion is being taken. So for example, when we take 92, 92 can be expressed as 2 raised to the power 2 into 23 in prime factors. Now when we compute the torsion for 92, we get 92 into 1 minus 1 by 23 into 1 minus 1 by 2, which comes out to be 44. So this indicates that 19 raised to the power of 44 will always give us a remainder of 1 when divided by 92 from Euler's-Torsion theorem. So once we get that 19 raised to the power of 44 will give us remainder of 1, it is very easy to compute 19 raised to the power 92 when divided by 92. Because 19 raised to the power 88 will always give us remainder of 1, and 19 raised to the power 92 is just computing the remainder when 19 raised to the power 4 is divided by 92. We know that 19 squared is 361, which gives us remainder of minus 7 when divided by 92. So 19 raised to the power 4 will give us minus 7 square, or 49, when divided by 92. So this concludes that 19 raised to the power 92 will always give us remainder of 49 when divided by 92. So this was the first question, which was based on number theory. Let us come to a second question, which is based on time and work, but with a slight twist. So let us read this question. It says that 3 people, A, B, and C, are working on a project. They take 24, 36, and 48 days to complete the task when working alone. And they charge rupees 2,000, 1,500, and 1,000 respectively for 1 day's work. Now, all 3 of them start working together on the task, but C leaves after working for 3 days. It is also known that any number of workers can be employed only up to 14 days starting from the beginning. This is an important part of this question. And we are asked to find how much is the minimum possible amount to complete the entire task. So, as we approach any question in time and work, let us assume the total units of work to be the LCM of 24, 36, and 48, which comes out to be 144. So we can compute the amount of work done by A, B, and C in 1 day. So this gives us 6 units, 4 units, and 3 units of work per day. Now we are told that all 3 of them start working together for 3 days initially, after which C leaves. So we can simply find the work done in 3 days by A, B, and C together, which is nothing but 6 plus 4 plus 3 into 3, which is 39 units. Remaining work is 105 units. Now this remaining work has to be completed by A and B together within 11 days. And we also have to minimize the total amount that we want to give to complete the entire task. So this is a very straightforward question, because A and B have to work for 10 days, and the amount of work they will complete in 10 days is nothing but 100 units of work. 6 plus 4 into 10. Now for this remaining 5 units, we don't need B. A alone can finish this 5 units of remaining work in 1 day, because it can do 6 units of work in 1 day. So this gives us the final answer, that A and B together work for 10 days after C leaves, and A finishes the remaining 5 units of work in 1 day. So total number of days worked by A is 3 plus 10 plus 1, which is 14. By B is 3 plus 10, 13, and by C is 3 days. So now we just have to find the total amount of cost incurred by A, B, and C working together, which is nothing but 14 into 2,000 plus 13 into 1,500 plus 1,000 into 3, which comes out to be 50,500 rupees. So this question, a similar question was asked in CAT 2025, and this question is just a modified version of that question. Let us come on to another question on Venn diagrams and set theory. So let us read the question. The question says that a school has 750 students, all of whom are enrolled in at least one sport, out of cricket, football, and tennis. It is known that 375 people like to play tennis, 450 play cricket, and number of students who like to play football is not given. Number of people who like exactly one sport is 400. And we are asked to find what is the maximum number of people who like to play football. So this is a nice question on set theory. It is a simple question. So we are told that 400 people like exactly one sport. This means that remaining people like at least 2 or more sports. So this gives us that 350 people like at least two sports out of the three. And we have to maximize the number of students who play football. So we can assume that students who like to play only cricket and tennis is 0. So let me just so this question might be more clear with the help of a Venn diagram. Let us say this is cricket, this is tennis, and this is football. We are told that 350 people play at least 2 out of the 3 sports, which means that this area, the shaded area, comes out to be 350 as per the question. And we are being asked to maximize the number of people who like to play football. So we can easily see that the number of people who like to play cricket is 450 and who like to play tennis is 375. So we can assume this to be 0, the number of people who like to play only cricket and tennis, because we want to maximize the number of students inside football, right? So if this comes out to be 0, this is nothing but 450 minus 350, which is 100. And likewise, this is 375 minus 350, which is 25. And we are also told that 400 students like exactly one sport, which means x plus 100 plus 25 is equal to 400, which means x is equal to 275. Okay, and we are being asked to maximize the number of people who play football. So this is nothing but 275 plus 350, because this is 0 and this area is 350. So this gives us 350 plus 275, which comes out to be 625. So the answer for this question is 625. So this is a slightly challenging question. Similar question was asked in XAT 2026, but this is a modified version of that question. So let us see what the question says. This question is based on time, speed, and circular races and streams concept. So the question says, Ayush and Pratibha are two people swimming in a pool in the form of a circular strip. And water flows in the circular strip at 1 meter per second in clockwise direction. Ayush and Pratibha start swimming at the same time from diametrically opposite points on the strip. Ayush swims in counterclockwise and Pratibha swims in clockwise direction. They swim at constant but different speeds, and the ratio of their speeds in still water is 3:5 in still water. Now we are given that Pratibha beats Ayush by 16 seconds when they start from the same point. And circumference of the pool is given to be 48 meters. We are being asked to find how much time will they meet again. After how much time they will meet again when they start from diametrically opposite points. So we are being given the ratio of speeds, the difference in time taken by Pratibha and Ayush to complete one lap of the circumference starting from the same point. And now we are given the length of the pool. So first we need to find their speeds, their relative speeds in the swimming pool. And only then we can find that after how much time they will meet again at the starting point. So let us assume the speed of Ayush and Pratibha to be 3x and 5x in still water. Then relative speed for them will be 3x minus 1 meter per second and 5x plus 1 meter per second. Because stream is flowing in clockwise direction and Ayush is swimming in counterclockwise direction. That's 3x minus 1. And for Pratibha, it is in the same direction, so 5x plus 1. And now just using this equation that Pratibha beats Ayush by 16 seconds. So time taken by Pratibha to complete one lap is 16 seconds less than the time taken by Ayush. So 48 upon 3x minus 1 is the time taken by Ayush to complete one lap of the pool. And 48 upon 5x plus 1 is the time taken by Pratibha. And this difference comes out to be 16. Solving this equation gives us x is equal to 1, which means that relative speed of Ayush is 2 meter per second and Pratibha is 6 meter per second. This directly follows that time taken by Ayush to complete one full lap is 48 upon 2 or 24 seconds. And likewise for Pratibha, it is 48 upon 6 or 8 seconds. And we are being asked to find after how much time they will return to their original position, which is nothing but LCM of 24 and 8, which comes out to be 24 seconds. So the answer for this question is that they will meet again at the initial starting position, which was diametrically opposite after 24 seconds. If we in this question, it can also be asked that after how much time will they swap their initial positions? That Ayush's initial position is occupied by Pratibha and Pratibha's initial position is occupied by Ayush. And that is also very easy to find because that would just be after 12 seconds. After 12 seconds, Ayush will cover half of the circumference and reach Pratibha's position. And likewise, Pratibha will reach Ayush's position in half the time. So in that case, the answer would have been 12 seconds. So this was a question on circular races. Now let's look at a question based on probability. So this question is simple, but it is slightly tricky. Let us see what the question says. The question says that a bag contains 4 coins, out of which 3 coins are fair and the 4th coin is unfair, with tails on both sides. Harry draws a coin out of the bag at random and flips it 3 times, with the coin coming up tails all the 3 times. And now we are being asked that if the coin is flipped the 4th time, what is the probability of getting a tail on the 4th flip? So this question is not as easy as it looks because we have to calculate the probability of getting a tail on the 4th flip, given that we obtained a tail on all the 3 flips initially. So this question will involve Bayes' theorem, and let us see how. So first we need to find that what is the probability of getting tail, 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 given that we chose a fair coin to flip. So this is just half raised to the power 3, which comes out to be 1 by 8. This is the probability of obtaining tail, 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 given we chose a fair coin. And similarly, the probability of obtaining tail, 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 given that we chose an unfair coin is 1, because unfair coin will always show tail in every flip. So the next thing is that probability that tail will be obtained on 4th flip with fair coin is half. So this is the probability that we will obtain a tail on the 4th flip, given that we chose a fair coin to begin with. And similarly, probability of obtaining a tail on the 4th flip, given that we started with unfair coin, will be 1. So now, as I stated earlier, catch in this question is to use Bayes' theorem to evaluate the probability of drawing unfair coin, given tail, tail, tail in first 3 trials. So let's consider the following events, U and F. U and F denote that we chose unfair and fair coin to begin with. And we have to find the probability that we chose unfair coin to begin with, given that we obtained tail, tail, tail in first 3 trials. This is nothing but P of U into P of tail, 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 given U, that we obtained tail, 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 given that we started with initially with unfair coin, which is what we computed here, that what probability of obtaining tail, tail, tail given unfair coin, which is 1, because unfair coin will always show tail. Okay, so this probability is simply probability of unfair coin into probability of getting tail, 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 given that we chose unfair coin, upon total probability of obtaining tail, 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 which is probability of choosing unfair coin into probability of tail, 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 given unfair coin, plus probability of choosing fair coin, given multiplied by probability of obtaining tail, 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 given that we started with fair coin. So probability of choosing an unfair coin is 1 by 4, because out of the 4 coins, only one is unfair. This comes out to be 1 by 4 into 1 upon 1 by 4 into 1 plus 3 by 4 into 1 by 8. Because probability of getting tail, 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 given that we started with fair coin, is 1 by 8. So this calculation comes out to be 8 by 11, which is the probability of obtaining unfair coin, probability of starting with unfair coin, given that we obtained tail, tail, tail in first 3 trials. And similarly, probability of starting with fair coin, given that we obtained tail, 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 is 1 minus probability of starting with fair coin, unfair coin. 1 minus 8 by 11 is 3 by 11. So this was the first part of the question. Now the next part is that what is the probability of getting a tail on the fourth flip, given that we obtained tail, tail, tail in first 3 flips, which is nothing but probability of obtaining tail on fourth flip, given that we started with fair coin, multiplied by probability of starting with fair coin, given that we obtained tail, tail, tail in first 3 flips. And this has to be summed up similarly with the unfair coin. So this is nothing but half, because the probability that a fair coin will show tail on fourth flip is half, multiplied by 3 by 11 that we obtained earlier. Probability of starting with fair coin, given that we obtained tail, tail, tail in first 3 trials. Half into 3 by 11 plus 1 into 8 by 11, which comes out to be 19 by 22. So this gives us the answer that a probability of getting a tail on the fourth flip, given that we obtained tail in first 3 trials, is 19 by 22. So we come to the last question, which is the simple question on polynomials and quadratic equation. So let's look at the question. Fx is a cubic polynomial defined as 27x cubed minus 9x squared plus 6x plus 20. Alpha, beta, and lambda are the roots of this polynomial, and we have to compute 2 plus 3 alpha into 2 plus 3 beta into 2 plus 3 lambda. So obviously, this question has to be approached through a shortcut and not by finding the sum of the roots and product of the roots, because that would be very lengthy. So we are being asked to find this expression. And if we look at it closely, this can be rewritten as minus 2 by 3 minus alpha into minus 2 by 3 minus beta into minus 2 by 3 minus lambda. We can take negative sign out of the brackets and we will get this expression only. Multiplied by 27, because this will give us 27 in the denominator. So if we have to find this expression, we just have to divide this by 27. Right, so the trick is that this helps us to evaluate this expression. Let us call this P of x. Now we observe that P of x is nothing but negative of f of minus 2 by 3. Because when we put f of minus 2 by 3 is nothing but this expression that we are asked to find. So now we can just substitute minus 2 by 3 in f of x and divide by 27, which will give us the expression that we are being asked to find. So when we substitute minus 2 by 3, we get minus 4, and this 27 has to be divided because it's a 27 in the denominator, which is not present in this expression. So thus we get the final answer as minus 4 by 27. So this was all from this session. I hope you enjoyed the session. Please leave a comment and tell us what you would like to see next. Thank you.